Hello, everybody. So, in the previous discussions, we talked about virtual machines and we talked about container model. So, well, uh, so far as containerization goes, it's very important to understand the workflow over here. So, as I said previously, there is something called an image, which closely resembles to a class in a object-oriented language. And so we must create our class or template first. This class will contain the definition inside it to actually which will be actually used to create an object of that class. So we must first create that class or Docker image. Now, a most fundamental thing to understand over here is just like in typical object-oriented languages, we create classes by compiling from source code, right? In this case, our source code will be a file named as Docker file. So whenever you look for an image or you want to create an image, first of all, search for something called a Docker file. This is basically the file which will contain instructions on how the image will be created. So building the Docker image using the Docker file is going to be the first step in your workflow. Now, we talked about layers previously, and again, I'm trying to re-emphasize that. While you know that we have base classes from which to derive our new class, base images from which to derive our new image, each instruction, each instruction given in the Docker file for our new image is a layer on top of the base image. So each instruction, mind you, each such instruction creates a layer on top of the base image. Think about it like peeling of an onion. Each layer of the onion, you can just correlate it to each layer in this image. Each instruction is actually creating a layer. Okay, so basically a layer is a set of file system images, and an image is at the end of the day a stack of layers that are applied one after the other to produce the final file system state. Usually images are based on other images, as we already saw, and they will inherit the layers of their base images. Now, giving an example of this, if we have built a REST API with ASP.NET Core and we want to package it into an image, what do we need? We will definitely not create an image from scratch. Instead, we want to base our image on Microsoft's ASP.NET Core runtime image. And the image, this image already contains the runtime needed to execute the application. And please remember that we won't bother about any operating system over here. When we are creating the image, we don't bother about the operating system over here. What we are bothered about is the application and its dependencies. We all know that the operating system is going to be the shared operating system of the host, which will host the container. So it's all about the application and its dependencies. Now assume that we have a microservices architecture with multiple REST APIs, multiple granular REST APIs, all based on ASP.NET Core. Now, typically, we would package each API into an image so that we end up with multiple containers corresponding to each REST API. And it's also to be remembered that each layer of our base image is basically a read-only layer. There can never be any write to those layers, because if it were so, then we would have ended up in a situation where a file system change made by one container would actually remove the file system changes in a different container. Okay, so basically changes to one container's file system could affect the file system of other containers. Now, hence, in order to give the containers a writable file system, and we already saw this previously in our diagrams, that a writable layer is put on top of the layers of the image. And this writable layer will contain all the changes done to the file system of that particular container. And this layer, this writable layer, is tied to the specific container that is being built. However, this layer, this writable layer will be removed when we recreate or remove that container, and all the changes will be lost. This is important because it's important to understand that containers are transient. Unlike virtual machines, they will get created and deleted quickly. So a container should never be storing important data in its writable layer. However, if there is a need to store persistent data, we will need to employ another feature of Docker, which is called volumes. What this means is, if we ever need to store persistent data, we would be mapping a folder of the container's file system as a Docker volume. So whenever the container will write a file inside that folder, it will never be writing it to the writable layer of the container. Instead, it will be writing it to the Docker volume. A Docker volume will never be tied to the container. It's basically, it will keep on existing even after the lifetime of that container. Another thing to understand over here is that, so we looked at this flow that first of all we build the Docker image from a pre image, from a base image using a Docker file, and then we run the container from that image, right? So everything is made possible using the container tool set called Docker over here. But the important question which may have come out in your minds is that, where does all these base images reside? Now, in a typical object-oriented language, all these base classes reside in DLL files. And these DLL files can be part of a NuGet feed. So if you remember how we install NuGet packages, right? We have this NuGet feed from which we have NuGet packages installed through package manager, and these NuGet packages bring DLLs in them, and these DLLs will consist of the base classes inside them. However, in the context of containers, where do these base images reside? There has to be a repository, a publicly publishable repository where we have all these images available. So what happens is that whenever we say Docker run with a name of the image, it basically goes and searches that particular image in a publicly available repository called Docker Hub. This is a public registry where all our publicly available images will be stored. So we all know about Nginx. Nginx is a lightweight web server. If we want to create a container out of Nginx, we don't need to create an image from scratch. An Nginx image may be available in the Docker Hub repository. So if we say docker run nginx image, it will just go and search the nginx image in the registry, download the image from the docker hub registry, and then it will run a container out of that image. Okay, so that's basically the concept of a container registry. A container registry hosts images similar to how a NuGet feed hosts NuGet packages. And Docker Hub is the default registry of the Docker CLI. So, summarizing this, containers are created from images, which are stacks of layers. Images inherit layers from base images, and layers are sets of file system changes. Images are pushed to a registry. So whenever you create an image, it's up to you though to push that image to a public registry. Having said that, there are private registries as well. There are private container registries as well. We will see them in our subsequent lab tasks. So images can be pushed to a registry and then pulled on demand when a container is created from an image. Remember, a creation of a container from an image is basically creating an instance of an object from its class. And the writable layer, containers add a writable layer on top of the read-only layers of the image. The writable layer is discarded when the container is deleted or recreated. And to store persistent data, volumes are used. Okay, so with that, I think we are fine with the Docker theory, container theory, and virtual machine theory. Enough of the theoretical knowledge for having an understanding of a solid understanding of the way things work in container world. We will now go ahead and look into, we'll be doing some hands-on lab tasks, which will involve containers and Docker images. Thanks guys for following this.